right, so let's go on page 65 when we're done. So last week we looked at similar triangles, and what we need to know at this point to prove that two triangles are congruent is to know that all three sets of sides are proportional and all three sets of angles are congruent, right? So for similarity, we have shortcuts, just like we had some shortcuts for congruence. So the first one is angle, angle. Now we looked at angle, angle, angle for congruence, right? And we decided that didn't work for congruence because they could be congruent, but maybe not. And but we did know for sure that they would be similar. But even still, this doesn't say angle, angle, angle. It just says angle, angle. Because if I have two angles in one triangle congruent to two angles in another triangle, what do you know has to be true about the third angles? They have to be congruent. So since that happens every single time, there's no need to go and find that third set of angles every time, because every time they would be congruent. Does that make sense? So it's just like an extra step that's not even necessary. So this isn't angle, angle, angle. It's just angle, angle similarity. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So just knowing this right here is enough. And yes, they could possibly be congruent, but I don't know enough information for that. But I know for sure that they are similar. So I can say triangle ABC is similar to triangle DEF. And remember, the order matters for similarity just like it did for congruence. Then side, side, side. We had a side, side, side congruence postulate. This is side, side, side similarity. And this says if three sides of one triangle are, well, they can't be congruent because then that would be the congruence postulate. Sides cannot be similar, proportional, okay? So if three sides of one triangle are proportional, to the three corresponding sides of another triangle, then the triangles are similar. So this setup you have right here really doesn't tell you anything. You just have two triangles and that's it. There's not really a way to label that they are proportional. But if I had this and I had either some information or side links to figure this out, then I would have to show that the length of AB over the length of DE. Okay, so that ratio itself by itself means absolutely nothing. Okay, that's just a ratio of corresponding sides. Then if I put AC over DE, if these two fractions are equal, then those two sets of sides are proportional. Okay, but that's still not enough because this is just two side lengths right here. And then I would have to put BC over EF. And if all three of those little ratios are equal, that would mean that the sides are proportional, and you have to show that for all three sets of sides. When you can show that, or you have that information, then you can say that triangle ABC is similar to triangle DEF.
For the AC, did you mean DEF?
Oh, what did I do? Oh, dang it. Yes, DF, thank you. I just want to see if you're paying attention. Good job. Thank you. Thanks. DF, yeah. DF, thank you. I can't even blame it on the heat anymore. This morning I was about to pass out. I really couldn't think. All right, we're all good then? Now that it makes sense? All right, so then we have side angle side. So this says if an angle of one triangle is congruent to an angle of another triangle and the sides including the angle. Okay? So what would have to be true about the sides? Can they be congruent? Proportional. Are proportional. Then the triangles are similar. Okay? So again, here we've got that two angles are congruent. Okay, so it has to be the included angle, just like for side angle side with the other one, or with congruence. But then I also have to show that the sides are proportional. So I could put AB over DE. Again, that by itself doesn't really give me anything. And that would have to be equal to BC over EF. If that's true, there's a set of congruent angles, and then the sides that the angle is included in are proportional, then they are similar. If I had done AB over DE and AC over DF, it wouldn't matter if those are proportional or not because the angle is not included in there and that wouldn't be enough information. Okay, so it has to be the correct set here. Once I have that, then I can say triangle ABC is similar to triangle DEF. Okay, we all good? So what is missing from what we did with congruence? We have side, angle, side, 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 side. Angle, angle didn't work for congruence. But what else works for congruence that we don't have here? Two angles in the included side. So angle, side, angle, and HL, and angle, well, angle, side, angle, 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 side, and HL. Okay, so let's think about that. For angle, angle, or I'm sorry, for angle, side, angle, if I just have one set of sides, is one set of corresponding sides enough to show a proportion? No, so those wouldn't work. Plus, I don't need them anyway, because whether I was going to do angle, side, angle, or angle, angle, side, then I have the two sets of angles, right? And with two sets of angles, I don't need a set of sides anyway, because of angle, angle. Does that make sense? So that's why there's less, but same kind of information. All right, any questions about that? You only have 3 shortcuts to choose from. All right, so now this says, verify that the triangles are similar. Is it asking me whether or not they are similar? No. Okay, so when you read the question or you read directions, it's very important that you think about what it's asking you. Okay, if you try and tell me that there's not enough information here, guess what? You're wrong, because it's telling you they are similar. You have to decide why and explain. Does that make sense? It's not a yes or no question. So it says verify. All right, so my only choices are angle, angle, side, and side, side, side. In this picture here in A, do I have any side lengths at all? No. No. Or any way to show that sides are proportional even? No. So side, angle, side, and side, side, side are not even an option. My only option then is angle, angle. Okay, so before I even start, I'm going to have a goal in mind, right? So I need to have 2 sets of angles, and none of them are marked congruent for me. So I want you to think, without speaking, about where a set of congruent angles could come from. All right, Michael, where could I get a set of congruent angles here? Okay, our verticals, so what about them? So they're congruent? Okay, y'all agree with that? Okay, so I can say angle PQT is congruent to angle RQS. And what would my reason be, Michael? Okay, because if they are vertical angles, then they are congruent. Okay, so a couple of things here. One of the worksheets that you're going to get back tomorrow is the one that was the congruent triangle practice, where there was all those, there's like 15 problems on the front where it was just you had to choose side, angle, side, 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 or whatever. But if whatever information wasn't given to you, such as maybe vertical angles, you were supposed to write that in there and explain why. And so many of you, I mean, it clearly said that in the directions, plus every single example I did was exactly like that. But a lot of you didn't do that. And if you don't do that on these, that makes them totally wrong. So you may have gotten 100 in Schoology, and that may not be what the grade book says now because you didn't actually do what you were supposed to on the paper. So if I'm going to show that these 2 angles are congruent, I have to label them. And I have to write down that they are congruent, like this right here. And I have to say why. Just saying vertical angles is not enough. You have to say vertical angles are congruent, or if they are vertical angles, then they are congruent. But not just vertical angles, and not just that they're congruent. Does that make sense? The statement, the congruent statement, and why, and have it labeled. All 3 pieces have to be there. Santos, Santos, Santos. Grab your stuff, come sit right here. All right, so now I need another set of congruent angles. Where would I get my other set of congruent angles from, Nathan? Okay, y'all agree with that?
You said TPR.
Uh-huh. Angle TPR.
Oh, angle. Oh,
Uh-huh. No, angle TPR and PRS, right? Those are right. Okay, they're congruent because alternate interior angles are congruent. Are alternate interior angles always congruent? No. If two lines are parallel. Okay. Now, did he have to name it? And you did a great job. But did he have to name them with 3 letters? No, he didn't. And that threw some of you off. But naming them with 3 letters is absolutely fine because you did it right and there was absolutely nothing wrong with that. However, I'm not going to because I want to write less. But and remember, I told you, if you've got parallel lines, it could really help you to extend this stuff so that you can see it better if you don't really see that. So I'm going to extend these lines. And then the transversal. So here is the set of congruent angles that he was talking about. So is it okay to just name them with 1 letter? Yes. Would it have been okay for Michael to name them with just 1 letter? No. Okay. So I'm just going to say angle P is congruent to angle R. Again, it wasn't wrong what he said. I just want to write less. And then I can't just say because they're alternate interior angles. And I can't say alternate interior angles are congruent. Okay. If 2 lines are parallel, then alternate interior angles are congruent. All of that has to be there. We abbreviated a lot, but you have to have all of those pieces. You can't just say if 2 lines are parallel, then alternate interior angles. Then alternate interior angles what? Okay, a lot of you just stop. Make sure you've said everything that needed to be said. Have I said enough to say that my triangles are similar? Yes. Could I have done these 2 steps here differently? Yes. Okay. Could I have, instead of even using the vertical angles, could I have used a different set of alternate interior angles here? Yes. Could I have used the vertical angles and the other pair of alternate interior angles? Yes. I mean, because there's 3 different things you can come up with, and it doesn't matter which ones, and it doesn't matter which order. So just so that you can see this, you've got parallel lines. I could have used this transversal also and had these 2 angles congruent. I don't need them at this point, but whether you use this set or the other set, it doesn't matter. They're both true. They just have different transversals. Okay, we good on that? Okay, so this statement right here gives me 1 set of congruent angles. This gives me another set of congruent angles, which is enough to state that the triangles are similar. So now I can say triangle PQT, okay, is similar. If I name the first one PQT, what does the second one have to be? RQS, okay, by angle-angle similarity. Okay, everybody okay with that? So all of that stuff is the verification. But again, it could look different than your neighbors and you still both be right, depending on what order or exactly what you said, and that's okay. Okay, we all good? All right, so let's look at this next one. Are these 2 triangles similar? Yes, they are, because they told me that from the question, right? I'm just supposed to verify this. Do I know anything about any of the angles?
No.
Yeah, I heard a yes and a no.
Oh, don't you know that like your 6 goes to that angle and then that 6 goes to that angle?
Okay, yeah. But what does that tell me? But what does that tell me, Xavier? Just tune them out. Tell me what that tells you then. If the 6 goes with the one angle and the 6 goes with the other angle, what kind of triangle is it? You got 2 congruent angles. It starts with an I.
Isosceles.
Isosceles. Okay. Are these 2 triangles isosceles? Yes. So in this triangle, are these 2 angles congruent? Yes. In this triangle, are these 2 angles congruent? Yes. Does that mean that all 4 of them are congruent? No, it does not. Okay, so I know within one triangle that I have congruent angles, but that doesn't get me anything to compare the 2 triangles. Does that make sense? Just because I have 2 isosceles triangles does not mean that they're congruent or similar or anything like that. Okay, so even though I do know something about the angles, I don't know something about the angles between the 2 triangles. Does that make sense? So I don't know anything about any of the angles, right? So that eliminates angle-angle. That also eliminates side-angle-side. So what's my only option? Side, side, side. Do you have at least all 3 sets of sides labeled? Yes. Okay, so our goal from the beginning is going to be side, side, side similarity. Now, what does line segment PQ correspond to?
RS.
PQ corresponds to PR. Okay, so the length of PQ over the length of PR equals 4 over 6. Can I reduce that?
3 over 2.
That would be 2 over 3. Okay, so then I'm going to do QR. What does QR correspond to? RS. So that's going to give me 4 over 6, and that reduces to 2 over 3. Right? It should be no big shock that you're getting the same thing, right? It's not like we expect to get something different. Actually, if I get something different, that tells me I did something wrong somewhere. And so then I'm going to have PR over PS, which is going to give me 6 over 9, but it has 6 over 9. If you just write 2 over 3, you are wrong, because that is, you don't get a 2 and a 3 from the picture. So all of you that want to cut corners and take a bunch of shortcuts, there are none you can take here and get it right. Not a single one. So don't even try, or you're just going to be wrong. Okay, so this shows me one set of sides. This is my other set of sides. This is my third set of sides. I show that all 3 of them get the same ratio, which means they have to be proportional. Since I have shown that, now I can say that triangle PQR is similar to triangle what? PRS by what? Side, 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 similarity. That's good though. We all good? Anything else? All right. Okay. So, got these 2 triangles here. Do I know anything about any of the sides? No. As far as like side lengths to show proportionality, I don't have anything I could do that. So I have 2 sets of angles labeled, but are the 2 sets of angles that I have labeled congruent to each other? No. Does that mean for sure that I don't have congruent angles? No, because I can find angle C, right? So I can say that the measure of angle C plus 43 has to equal what? 90. So the measure of angle C is equal to what? 47. Okay. Which means that this is 47 degrees. Now, is there a need to go find angle D? No, there's not. So I'm good now. And I feel like I could probably show these are similar by what? Angle, angle. Okay, so there's my goal before I start, so I know what I'm even supposed to be writing down. So I'm going to start with saying angle B is congruent to angle what? E. Is that something that they just flat out told me?
Yes.
Well, no, because
No. Does this label right here mean congruent? No. They told me that they are what? That they are right angles. Are they congruent? Yes. Not because they told me, because that's not what they told me, and not because it was given to me, but why?
because they're right angles.
Not because they're right angles, because all right angles are congruent. All right angles congruent. Okay? That has come up a lot already, and y'all still want to tell me that it's given. You still want to just say because they're right angles. Or you say stuff like all right triangles are congruent. That makes absolutely no sense. So think about what you're saying, otherwise what you're saying isn't right. Okay, so then I know that angle C, or can I say that angle A is congruent to angle D?
Yes.
No, I absolutely can't. No. I only have one angle, or one set of angles, so I can't use the third angle theorem here. That doesn't make any sense. But 43, I don't have this, so I can't use those, but I can say that angle C is congruent to what? Angle F. Okay, was that given to me? No, I had to go find something. Now, if I had done angle C plus 43 plus 90 equals 180, then I could say it's the triangle sum theorem. But we didn't do that. We used a corollary from that, and we got that because the acute angles of a right triangle are what? What's the word? Complementary. Okay. So now I have, this is one set of angles. This is the second set of angles. That's enough to say that the triangles are similar. So I can say triangle ABC is similar to triangle what? DEF. By what? Angle, angle, similarity. Shh. Okay, we good? Any questions? All right. So now let's look at this one. Did they tell me anything about any of the angles? No. Do I have all three sets of sides? No. Do I have enough information to find the third set of sides? No. I don't really know how you would find them, but no. Okay, so I can't find all three sets of sides, which means side, side, side is not a possibility. How many triangles are in this picture?
Two.
That third thing has four sides. Okay. All right, so I only have two triangles here. Might help to separate and redraw them. So if I redraw them, and this is going to give me JKL and JMN. I got to get at least one congruent angle from somewhere. Cameron. Are corresponding angles always congruent? No. Only when what? The sides are parallel. Do you know that those are parallel for sure? No. Yes? Okay, what about angle KJL and MJ, and what about them? Why would they be congruent? Okay, close. Michael? The reflexive property, because it's the same angle. It's not that they're on the same line, it's because they're the same angle, right? And anything can be congruent to itself, so it's the reflexive property of congruence, angle J. So when I come over here, this angle is congruent to this angle. Does that make sense? So you're on the right track there, Santos. Okay, so now let's label the rest of this on here. This is 2, this is 3. What's the length of JM? 6 and 9. Should have the whole thing. So what can I use? What does it look like I could probably use here?
The side angle side.
Side angle side. Okay. Okay, so we're going to start with the sides. We'll start with JK, the length of JK over the length of JM. That's going to give me 2 over 6, and what does that reduce to? 1/3. Then JL over JN. It's going to give me 3 over 9, and that gives me 1/3. So this is a set of sides, and this is a set of sides. So I've got my two sets of sides. My angle, I can say angle J is congruent to angle J. Why? Reflexive property of congruence. Now that has come up like multiple times, every single time we have talked about anything with justifying. But still, so many of you just put reflexive or reflexive property. And that makes it wrong, because there's a reflexive property of equality, there's a reflexive property of congruence, there's a reflexive property of similarity. Which one are you using? The only one that makes sense is congruence here, so it's not even that hard, but you have to write it. Okay, yes, sir?
I thought we had to put 3 angles.
There's only one angle that's actually coming off of there. It's angle J. So here, angle J is congruent to angle J. Right, only if I wanted to say angle K right here. Then it would be like JKL or LKM, like I don't know which one you're talking about. But if we say angle J, whether it's this situation, this one, or this one, there's no question about what angle it is. Does that make sense? Now, can you use 3 letters? Absolutely. But we don't need to. Okay, so here's a set of angles. Now, although this is not in the side angle side order, that doesn't matter. The order in which you write it and explain it does not have to match what's going on in the picture. What matters is in the picture, are there two sets of sides in the included angle? And there is. So that's enough there to say that my triangles are similar. So triangle JKL is similar to triangle JMN by what? Side angle side similarity. And all of that stuff is part of your answer. You leave off any of it and you are wrong. Okay? All right, so look down underneath this. Put the glue down. Actually, put it all the way back in the box. Thanks. Okay, properties of similarity. So we have properties of equality, properties of congruence. Now we're going to look at properties of similarity. So the reflexive property of similarity, remember, we had one of congruence, we had one of equality. So if it's the triangle ABC, that would be similar to triangle what? ABC. If it is reflexive, it is the exact same thing. That's why it was angle J is congruent to angle J. You cannot change it up anything. When you look in the mirror, you see yourself, okay? Just like they do, okay? Symmetric property. So symmetric is where it gets flipped around. So if triangle ABC is similar to DEF, then triangle DEF is similar to what? Triangle ABC. And then the transitive is where we cut out the middleman here. And so if triangle ABC is similar to DEF and DEF is similar to XYZ, then triangle ABC is similar to XYZ. Triangle YC. Okay. All right. Any questions at this point? All right. Now you can go ahead and glue it in. Okay, so grab the homework. On 1 through 6, you don't have to do all of the explaining that we just did, but what you do have to do is show the proportions. Like if you're going to use side, 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 or side, angle, side, or no, yeah, side, 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 or side, angle, side, then you have to show the proportions on 1 through 6. The rest of it, you don't have to do a ton of explaining. On the rest of them, the lines are there because you need to do the explaining like you did in the notes. If you look at number 8, you see on number 8 how they have some angles labeled? Okay, those are just given. So if it's literally given to you, then your reason is just given. Does that make sense? Okay, so 7 through 13 requires explanations, right? 14 and 15 don't require any. And then you're putting some of this into Schoology, but some of it obviously I'm grading off the paper. So we good? So you got at least 10 minutes left. You need to make good use of that time and work until the bell.